Hi, welcome to Marker Board Videos. Today's video is about the periodic table and taking it apart and getting the information that's in it out of it so that you can use it. So the first thing is when you see one of the squares or one of the cells on the periodic table, it looks something like this. So let me decode that for you. The middle, the abbreviation, is either one or two letters, and that's your atomic symbol. It tells you what element you're talking about. The number is usually a whole number, and usually it's on the top, but not always. Look for the whole number. The whole number is your atomic number. It tells you how many protons. If you counted the protons, it would actually identify what this is. Ag is silver. Silver always has 47 protons. If you find something and you don't know what it is, and you count the protons and there's 47, you know it's silver. The bottom number is the atomic mass, and again, because of isotopes, it's not always a whole number. In fact, rarely. I don't know if it's a whole number ever, but this is the atomic mass, and it tells you if you added up the mass of the protons and the neutrons, this is what you would get. When you're going to use this to do counting protons and neutrons, or to do Bohr models or any of those kinds of things, you're always going to round it to the nearest whole number. So here we go, the actual periodic table, which looks like a big mess, and it's sometimes very intimidating, but let me take it apart for you. These are rows, and these are columns. So let's start with the columns. The columns are families, or sometimes called groups. And everything in a column has a similar characteristics. Just like in your family, people have similar characteristics, so it is on the periodic table. So hydrogen, lithium, sodium, potassium, etc. all have similar characteristics. So do helium, neon, argon, and krypton. They have similar characteristics. Now above it, you'll either find the Roman numeral, you'll find the number 1 through 18, or you'll find 1A, 2A, and then there's B's in here, the transition metals, and then 3A, 4A, 5A. So it gets confusing. What if it says 13? What does that mean? Well, for any one that's higher than 8, just take the 1's digit off. Takes the 10th digit off. So 13 becomes a 3 again, and 15 becomes a 5, and then they'll make sense to you. It's exactly the same. So when you go across on the rows, we've already talked about it. Those are periods, and those tell you how many energy levels. So in a previous video, we had potassium, and I said it was at level 4, row 4, so it had 4 energy levels, and it does, 1, 2, 3, 4. So the family names, everything in group 1A is called an alkali metal. Everything in group 2A, their family name is alkaline earth metal. These B's, or these ones in the middle here, are called transition metals. We're going to skip 3 through 6 for a minute. 7A is called halogens, and 8A is called noble gases or inert gases. Noble gases or inert gases. And these are usually named according to the first thing in their group. So this is the boron group, the carbon group, the nitrogen group, and the oxygen group. But the most important ones that you should memorize are these 4 right here: 1A, 2A, 7A, and 8A. So let's talk about a thing called valence electrons. Valence electrons are the number of electrons that are in the outermost shell, or the outermost energy level of an atom. They're the ones that are going to be part of chemical bonding, so they're very, very important. Every atom wants to have 8 electrons in its outermost shell. If it can't have 8, it'll settle for 2, but it really wants 8. 8 is the magic number. So in the case of this element, which happens to be hydrogen, you have your protons and your neutrons, and there's 1 electron in the outer level. That means there's 1 valence electron. This one right here, there's 2 electrons in the inner level and 1 in the outermost level. 1 in the outermost level, again 1 valence electron. And in this one right here, we have 8 and 8, which is 16. So we have 8 electrons, 2 in the inner level, 6 in the outer level. The highest level, the most far out level, is the one that has 6, so there's 6 valence electrons. Now the fact that it wants 8 has a special name. It's called the Octet Rule. Octet Rule. And oct means 8. It's the rule of 8. And basically what it says is an element will do what, an atom, will do whatever it has to get 8. It will give up electrons, it will take extra electrons, or it will share electrons, but it will do whatever it has to get 8. Now remember, hydrogen and helium are special cases. Things will settle for 2 if they have to. They'd rather have 8, but they'll settle for 2. But 8 is the magic number. That's called the Octet Rule, and it'll do absolutely anything that it has to get those 8. That's why we have chemical bonds.